going to be looking at proportional reasoning. We are going to be solving a real-life problem that involves ratio, rate, and a directly proportional relationship. We're going to make comparisons in this example using unit rate. A unit rate is a rate in which the second term is 1. For example, if we said that the rate you get paid per hour is $10.25 per hour, this is a representation of a unit rate because the second term is 1. For every 1 hour, you make $10.25. This example compares the amount earned to 1 hour of time. Now let's look at a problem that involves using unit rate. Adriana works at a veterinarian's office. She needs to give a dose of medicine to a 22-kilogram dog. The recommended dosage for a dog that weighs 12 kilograms is 30 milliliters. Determine the dosage Adriana should give to the 22-kilogram dog if the rate remains the same. Show your work. Now this question does tell us that there is a rate, but we need to figure out what that rate is. So first we have to figure out what are the two quantities being measured here. Can you figure that out? Look for units in the question. Well, we have kilograms here, and we have milliliters. So maybe there's a comparison between kilograms and milliliters. Let's fill in the numbers. It says the recommended dosage for a dog that weighs 12 kilograms is 30 milliliters. That means that you need 30 milliliters for every 12 kilogram dog. Well, how do you know that this is a rate? Well, we're comparing milliliters to kilograms. So this is the rate. But does this represent a unit rate? Remember, a unit rate is a rate in which the second term is 1. So we need to figure out how many milliliters do you need for 1 kilogram. So now what? How do we find the missing value? Well, think about how these two rates are related. What can I do to 12 to get to 1? 12 divided by something gives us 1. Well, anything divided by itself is an answer of 1. So if I divide 12 by 12, I get an answer of 1. What do you think you need to do to the other term? If I divided the second term by 12, well, then we need to divide the first term by 12. So let's do that. What's 30 divided by 12? 30 divided by 12 is 2.5. That means that for every 1 kilogram, we need 2.5 milliliters of medicine. So now what can we do with this information? Well, let's go back to the question. The question said that Adriana needs to give a dose of medicine to a 22-kilogram dog. We need to find the dosage, so how many milliliters, Adriana should give to this dog if the rate remains the same. Well, now that we know the rate, how can we figure out how many milliliters the dog needs if he weighs 22 kilograms? So let's think about this. If the unit rate is 2.5 milliliters for every 1 kilogram, can we figure out how many milliliters we need for 22 kilograms? This is actually going to be a new rate. So let's look at how these two rates are related. Well, if we're increasing the size of the dog to 22 kilograms, how do I get from 1 to 22? We can multiply it by 22. 1 times 2 is 22. And just like we did before, whatever you do to one term, you must do to the other term. So what do I need to multiply by 22? Good. We need to multiply the first term by 22. So let's figure that out. 2.5 times 22 is 55. That means we need 55 milliliters for a 22-kilogram dog. Well, how do we know that our answer is correct? Well, the question told us that the rate must remain the same. That means all of these rates should be equivalent. Let's check to make sure they are. Well, the question told us that the rate was 30 milliliters for every 12 kilograms. We found a unit rate of 2.5 milliliters for every 1 kilogram, which means that you need 55 milliliters for every 2 kilograms. I've chosen to rewrite all my rates as fractions: 30 over 12, 2.5 over 1, and 55 over 22. Now there's a few ways that we could compare these fractions to make sure that they are equivalent. Can you think of one way that you can compare these fractions? Well, one way we could do this is by finding common denominators. If all the denominators were the same, it would be easier to compare these fractions. Can you see a denominator that would be common between the three of these? It might be a little harder to do in your head. So let's think of a different way that we could compare these fractions. Well, can you think about how you could turn a fraction into a decimal? Can we reduce these fractions? To turn a fraction into a decimal, we would take the numerator and divide it by the denominator. So let's do that on our calculators. 30 divided by 12 gives us an answer of 2.5. What's 2.5 divided by 1? It also gives us 2.5. What do you think 55 divided by 22 might be without even using your calculator? Try it. Of course, the answer is 2.5. This just helps to prove that all of these rates are in fact equivalent. Now that you know this information, do you think you could figure out how many milliliters you might need for a 25 kilogram dog or a 50 kilogram dog? Try it. Well, now that we've done all this, let's answer the question. The question asked us to determine the dosage that Adriana needed if the dog weighed 22 kilograms. Therefore, Adriana needs 55 milliliters of medicine for a 22 kilogram dog. Can you think of other strategies you could have used to solve the same problem? Check out our playlist to find different solutions for solving the same problem.